Hi everyone. So today in this video we'll be discussing about Markovnikov rule. So what is Markovnikov rule? Let's see the definition first. To an unsymmetrical reagent added to a unsymmetrical alkene, the negative part of the reagent will get attached to the carbon atom which contains a very lesser number of hydrogen atom. So that means we have a alkene family. Okay, so here if you see we have propene, and to that we have been adding a reagent which is hydrogen bromide. Okay, so the reagent here what we have chosen is hydrogen bromide, but it can be any halogens. So it can be fluorine, chlorine, bromine, iodine. So how do you attach this reagent to this alkene family? So in alkene, if you see, there is sigma bond and there's one pi bond. So pi bonds are actually very reactive, so easily they can break and then accept the incoming group, it can get attached to it. Okay, and you will be getting a product like this. But then the question is, why there is only two bromopropane? Okay, why the bromine is getting attached only to the second carbon atom and not to the first carbon atom? So that is what is the topic you will be discussing in this Markovnikov rule. Okay, so now here in case we have symmetrical alkenes, okay, and there is unsymmetrical alkene. If there is a symmetrical alkene, you can attach the bromine either to this carbon atom or this carbon atom. That means let's just on either side of the carbon, I mean double bond, any carbon atom you can attach the bromine atom and you will get the product. So that's going to be simple. But then in case of unsymmetrical alkenes, will you attach to this first carbon atom or second carbon atom? So that's the question. Okay, so that is what you will be learning according to the Markovnikov rule. So you have to make sure that the reagent, that is a negative part of the reagent. So the reagent, okay, that is a negative part of the reagent, that is nothing but the bromine atom in this reagent, okay, hydrogen bromide, should always get attached to the carbon atom which has lesser hydrogen. So the bromine will go and attach to the carbon-carbon double bond which has lesser hydrogen, not to the carbon which has more hydrogen. And to the carbon which has more hydrogen, the hydrogen part will get attached. Okay, we'll understand why. So before we start off with this, you should be knowing carbocations. So what is a carbocation? A carbon which has a deficiency of electrons, then they form a carbocation. And here if you see, we have different types of carbocation: primary, secondary and tertiary carbocation. So what is a primary carbocation? So if suppose if there is one R alkyl group and two hydrogen, then it is primary carbocation. If suppose there are two alkyl group and one hydrogen, it's secondary carbocation. If there are three alkyl group and there's no hydrogen, it is tertiary carbocation. And the stability, if you see, tertiary is greater than secondary, greater than primary. Okay, we'll come back to this concept. So now we will understand what is this mechanism. Okay, so how this particular 2-bromopropane is obtained from two propane. Okay, from propane, how are we getting 2-bromopropane? So now we will see the mechanism. So first of all, hydrogen bromide will split up into hydrogen and bromine, because bromine is more electronegative. It tends to pull the electrons and it forms Br minus. And we know that Br acts like a nucleophile now. Okay, and now we will take this reactant. Okay, we will take this reactant, that is CH3, CH double bond CH2. Okay, so I will tell two possibility of product obtained, and in that what is your major product and how, where does the bromine go and attached. So first possibility, now if you see this hydrogen, I'll just add it up here. Now this pi bond can easily break down, and this pi bond can either shift to this side or this side. So one way I will show you, that if suppose the pi bonds are shifting to the, let me number it as carbon 1, carbon 2 and carbon 3. If suppose the pi bond is shifting to the carbon 1, okay, then the carbon 2 will be getting a positive charge and carbon 1 will get a negative charge. Okay, and this particular carbon 1 which has a negative charge, it has extra electrons, correct? So that will obstruct this proton, and as a result, okay, as a result we have this product CH3, CH carbocation, and then we have CH3, the CH2, and obstruct one proton and form CH3. Okay, so this is what type of carbocation? It is a secondary carbocation which has one alkyl group and one carbon, hydrogen and one more alkyl group. So it is a secondary carbocation, secondary carbocation. Okay, so this is one way. So let's see the other side also. Same reactant I will take. Now this pi electrons, I'm going to shift it to the second carbon atom. So if the pi electrons are shifting to the second carbon atom, so what's going to happen? This carbon which is taking the pi electrons will get a negative charge, and the first carbon gets a positive charge. The first carbon forms a carbocation, and this second carbon will abstract this proton because it has a negative charge, it has extra electrons, and then we will be getting some product like this CH3, CH2. CH is becoming CH2, and then we will be having this CH2 with positive charge. Okay, now this is what type of carbocation? So it is a primary carbocation. So it is a primary carbocation because there is 2 hydrogen and there is 1 alkyl group. Then it is a primary carbocation. And you should know the stability. Primary carbocation is more stable or secondary carbocation. So as previously I told you, we have 3 types of carbocation. So in case there is something like this with 3 alkyl group, then it is tertiary carbocation. If suppose there is 2 alkyl group and there's 1 hydrogen, then it is secondary carbocation. Okay, secondary carbocation. And now what is primary carbocation? So here if what is going to happen, here I have 3 and here 2, then how many alkyl group will be there? There's only 1 alkyl group. Okay, and then we have 2 hydrogen atom, then it is primary carbocation. Now if you see, this carbocation means deficiency of electron, right? So that means it has very less electron. So what happens, till this incoming group, that is your nucleophile bromine, before till it comes and approach here, this carbocation has to be stabilized. So this methyl group, here if you see methyl, ethyl, alkyl groups, usually are electron donors. They will try to stabilize this carbocation by giving its electron. So since we have 3 alkyl group, so it is more stable. Here only 2 alkyl group, so it is less stable. And then, but whereas in primary carbocation, it is very less stable because there's only 1 alkyl group. Okay, so in order to know the stability, you should see this. Tertiary carbocation is more stable, and compared to tertiary is more stable compared to secondary, compared to primary. So let's come back to this. So there are 2 possibilities. So if you see, there is secondary carbocation obtained and primary carbocation obtained. So which carbocation is more stable? Secondary carbocation is more stable. That's why the bromine always wants to preferably attach to the second carbon atom. So let's come back to that equation. Okay, let's come back to this equation. Why we got 2 bromopropane instead of 1 bromopropane as your major product. So I will write down the reaction again. CH3, CH, double bond CH2 plus hydrogen bromide. So what is your expected product, your major product? Your major product will be CH3, CH. Here you will be attached. The second carbon atom will be where the nucleophile will come and approach. That is your bromine atom, and then CH3. Okay, so here the second position you will be having a bromine attached. So since it's second position, the carbon second position is bromine attached, so the name of this group is 2-bromopropane. This is your major product. Okay, so as we know that secondary carbocation is more stable than primary carbocation. You have to approach the nucleophile to the second carbon then rather than the first carbon atom. So this is what is the mechanism, and this is what is Markovnikov rule. Okay, so for 1 mark question, you can directly write down the product. Wherever lesser the hydrogen, just directly attach the bromine that side and the hydrogen on the other side. But you should know why it is happening. So to know why is it happening, you should know about the stability of carbocation. Okay, thank you so much.